Before starting the next lesson, try this warm-up. Calculate the area and circumference of the circle. So here's the circle. The radius is 5 centimeters. Pause the video, calculate the area and the circumference, and see how you do. Okay, so two formulas that you may have remembered from previous grades. Area of a circle is pi r squared. Circumference is 2 pi r. So if we know what r is, we can just plug those values into our equations and solve. So we should end up with 78.5 centimeters squared for the area of the circle and 31.4 centimeters for its circumference, which is the distance around the outside. Now, we're not just going to talk about area and circumference of circles. We're going to get a little more detailed. We're going to up the ante here. We're going to talk about arc length and sector area of circles. But really, these two concepts build on what we just did in the warm-up. So the goal for this lesson is for you to be able to determine the length of a line segment within a circle, determine the measure of the arc, determine the sector area of a circle, and the measure of the central angle. So we'll do examples that cover all those things, and here we go. The first thing we want to talk about is the chord division theorem. Remember, a chord is the line segment that joins two points that are on the circle. Okay, so this part right here is a chord. A radius drawn perpendicular to a chord. So here's the center of the circle. This is my radius. It's drawn perpendicular to the chord. It will bisect the chord. So bisect means cut it in half. So here I've shown you this line segment and this line segment are the same length. Okay, this rule you need to keep in mind as we go through this. So for the first example, we're going to determine each unknown. So the unknowns are x in both cases. All right, so anytime I label O, that means we're at the origin or the center of the circle at this point. Okay, so from the center of the circle to the chord, I have a right angle. And because this is a right angle, that means this is a right triangle, so that means Pythagorean theorem is going to work. So x squared plus 6 squared equals 9 squared, and we solve for x. We get x is the square root of 45, which is about 6.7. All right, in the second one here, all right, I've got the center of the circle here. Here's a chord. This line is meeting the chord at a right angle. So I have a right triangle here. That means 4 squared plus 6 squared equals this side squared. Now this side is from the center of the circle to the outside. That's the radius. This line segment from the center of the circle to the outside, that's also the radius. So x is the radius. That means this length and this length are the same. So when I solve Pythagorean theorem, I'm actually solving for x. So 4 squared plus 6 squared equals x squared. When I do that, x is the square root of 52, which is about 7.2. Now let's talk about arc length and sector area. So recall from the warm-up, circumference is 2 pi r, area is pi r squared for a circle. So remember, this is the circumference of the entire circle. This is the area of the entire circle. So if we want to calculate the arc length, well, that's only a fraction of the circumference. And when we want to calculate the sector area, well, that's only a fraction of the entire area of the circle. Okay, so we're going to start with these formulas for circumference and area of a full circle, and we're going to make an adjustment so that we end up with not the circumference, but the arc length, and not the area, but the sector area. And it all hinges on knowing what this angle is. I'm labeling it theta, so that'll be the central angle, the subtended angle between the two radii. So let's start with arc length. It's not just the distance from this point to this point in a straight line, because it follows the curve of the circle. As I said earlier, it's a fraction of the circumference. So we're going to start with circumference, so 2 pi r. Now this fraction of the circle, the full circle all the way around is 360 degrees. And if we're taking up only theta degrees, then we're taking up theta over 360 as a fraction of the circumference. So we're going to take this circumference and multiply it by theta over 360. Okay, so we've got the circumference of the circle multiplied by theta over 360. So we're getting the fraction of the entire circumference. And this is what we call the arc length. Now I can take this and I can put it into lower terms because 2 over 360 is 1 over 180. So I end up with the arc length equals theta times pi times r divided by 180. Now if I want to calculate the sector area, the area just of the sector, I can do a similar thing, except I'll start with the area formula for a full circle, pi r squared. But remember, that's the area of the full circle. I only want a fraction of that circle. So what fraction of the circle do I have? Well, it's theta over 360. So if I multiply this by theta over 360, I end up with my formula for sector area. Sector area is theta times pi r squared divided by 360. So these formulas for arc length and for sector area, you want to make sure you have those written down that you can refer back to them as we go through the examples. So here's an example. Determine the arc length and sector area. So here's my circle. The radius is 10 centimeters. The arc length will be from here along the large part, the sector, to here. I want that arc length and what I've highlighted in my green scribbles here as the sector area. So this 250 degree angle is from here to here. It's this angle right here. Okay, so you should have enough information to try this on your own. So pause the video, calculate the arc length and sector area, and then check back in to see how you do. Here's how I got it. The arc length, I've just called it arc for short, theta pi r over 180. Theta is 250 degrees, r is 10 centimeters. 250 times pi times 10 divided by 180 is about 43.6 centimeters. So my arc length, distance around the circle from here to here, 43.6 centimeters. The sector area, or A sector, as I've labeled it, theta pi r squared over 360. Sub in my values for theta and r. Do the calculation. It's about 218.2 centimeters squared. Remember, centimeters squared because it's area. This last example is a little bit different. Determine the arc length and central angle. So this time, we don't know what this central angle is, but we do know the radius and we know the area. Okay, so I'd like you to try this on your own. Knowing the area, find the central angle, and then you can find the arc length. So pause the video, try this question, and see how you do. So I started with the sector area formula, theta pi r squared over 360. I know the sector area is 300, so I replaced 300 in here. I know the radius is 15, so I replaced r with 15. And now I want to solve for theta. So that means I need to multiply both sides by 360 and divide both sides by pi 15 squared. So that's where I got this from, 300 times 360 divided by pi 15 squared. When I do that in my calculator, I should get 153 degrees. If you didn't get this, probably what happened is you just typed this whole thing in your calculator, 300 times 360 divided by pi times 15 squared, and you didn't put any brackets around the numerator or any brackets around the denominator. So just watch out for that. You're probably just missing brackets around the numerator and brackets around the denominator. You should get 153 degrees for theta. Okay, so now we know the angle in here is 153 degrees. And I can use that to calculate the arc length. theta pi r over 180. Well, theta is 153 degrees. R was 15 centimeters. Do that in the calculator, you get about 40.1 centimeters. So the distance from here along the circle to here is 40.1 centimeters. All right, so hopefully you've got those formulas for arc length and sector area written down. You're going to use those in the practice questions. If you run into any trouble with the practice questions, please reach out and I'll do my best to help.